Dear students, let us continue our study of the number system. So in the previous class we have seen two number systems, that is a decimal number and the binary number system. Now let us go to the third one, that is octal number system. Now here in case of octal number system, the radix or the base is 8 and its powers are used. So these there are 8 numbers. So when I say the base is 8, there must be 8 numbers. Which are these 8 numbers? So they are similar to the numbers which are used in the decimal number, starting from 0, 1, 2, 3, 4, 5, 6 and 7. So altogether 8 numbers are used. So since it has the base 8, or they are also called as 8-bit number system. So this octal number system is commonly used in the computers like mini computer and micro computers, right? So this is the application of this. Now we are making use of the powers of 8 here, as I told you. So they are 8 to the power 0, which is it is 1, 8 to the power 1, that is 8, then 8 to the power 2, that is 64, 8 to the power 3, that is 2056, I think. Sorry, 512. 512. Then 8 to the power 4, it is 4096. 8 to the power 5, it is equal to 32768 and so on. So we are making use of the 8 to the power. Its value is to be used in conversion from the decimal number system to the octal number system, right? So now, as I told you, the octal number system is frequently used in digital circuits due to its principal reasons, that is it can be easily converted to the binary. So easily you can convert a octal number to a binary number, and there are only fewer significant digits, right? So in any given octal number. Now the octal number system is, as I told you, it is mainly used in computers and microcomputers for entering the data. There are 8 combination of 3 bits. So there are altogether there are 8 combinations of 3-bit binary numbers. So you know that in case of the combination of 3 binary numbers, so that is taken as a bit in octal number system. Now say in counting the higher numbers, so these are the primary numbers which are commonly used. So in counting the higher numbers, so we are making use of the numbers like it is 1 0, 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 1 7. So 1 8 and 1 9 is left out. Here 8 and 9 are left out. Similarly, this is 2 0, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, 2 7. So like this you can continue, right? So this is how we can count the higher numbers. Now, as I told you, to count the fractions. So as we are considering in the decimal system or the binary system, we are using 8 to the power minus 1, 8 to the power minus 2, 8 to the power minus 3, 8 to the power minus 4 and so on in counting the decimal fractions. So we are making use of 8 to the power minus 1, minus 2, minus 3 and minus 4 and so on, right? So now let us consider some of the examples here. Let me consider one example, that is a conversion of an octal number into its decimal equivalent. Conversion of an octal number into octal to its decimal equivalent. how to convert any given number, octal number, to its decimal equivalent. So, as we have done in the previous cases, binary to decimal, you know how to convert it. So, let us consider one example. Say the example is convert. So, octal number to decimal number. Now, say for example, there is a octal number, say 342, which is represented in the or which is given in the octal number system. How to convert it into a decimal number? So, to do that, now as we have done in the earlier case, 3 into 10 to the power 8 to the power 2 plus 4 into 8 to the power 1 plus 2 into 8 to the power 0. So, this is what we have to do. Now, 3 into 8 to the power 3 into 64 plus 4 into 8 plus 2 into 8 to the power 0, it is 1. Therefore, 3 into 64, it is 192 plus 32 plus 2. Add them. So, 2 plus 2 plus 2 is 6. Then it is 2. Then 1 9 plus 3 is 12. So, this is 2. So, this is the equivalent decimal number. So, 342 in octal number system, that is equivalent to 226 in the decimal number system. Okay. Similarly, if you consider a fraction, so let me consider one example of fraction. How will you convert that? So, for example, you consider 764. This is given in octal number system. So, what is its equivalent value in the decimal number system? So, we can do the same thing as we have done in the earlier case. So, 7 into it's 8 to the power minus 1 plus 6 into 8 to the power minus 2 plus 4 into 8 to the power minus 3. That is 7 into 1 by 8 plus 6 into 1 by 8 square is 64 plus 4 into 1 divided by 8 cube is 512. So, these are the fractions. Multiply and divide. Now, I will write you the actual value. So, 0.875 plus it is 0.09375 plus 0.0078125. Alright. So, add them. You will get the value 0.9765625. So, this is an equivalent decimal number. So, 0.764 in octal number system, that is equal to 0.9765625 in the decimal number system. Right? So, now let me consider one more example. That is 35.27 in octal number system. How will you write it in the decimal number? So, 3 into e to the power 1 plus 5 into e to the power 0 plus 2 into e to the power minus 1 plus 7 into e to the power minus 2. So, this is 8 3 is 24 plus 5 8 1 is 5 plus 2 into 1 by 8 plus 7 into 1 by 8 square. Now, if you simplify this, it is 35.9375. So, this is in decimal number system. So 35.27 in octal number, it is equal to 29.359375 in the decimal number system. So this is how you can convert it into a number, octal number into a decimal